Yeah, that's right. You guessed it. We're going to be graphing a function rule today. So in order to graph a function rule, we got to get a function rule. So here's a function rule. Now this function is f of x is equal to 3x minus 2. And this is the way it would be presented to you. So from this, what you're going to do is you're going to make a table of values. Okay. Now there's a couple different tables you can make. I know starting off, I teach my students to make this in 3 columns. And this is going to be your x here. This is going to be your y here. Actually, we're going to add a 4th column because you'll see why in just a second. Okay, and then in here is going to be whatever the function rule is. And then we're going to pick some values. Because we're using this very typical Cartesian coordinate plane, we're going to use values that are all kind of centered right around here. So these are the numbers that we like to use. Again, provided the function is cooperative. I'll show you what it means when the function's not cooperative in a minute. So what we're going to do is we're going to substitute in this x value, right? And we're going to put that right in here for x, and that's going to go in this row. So we're going to have 3, and then in parentheses, that negative 2 is replacing x, and then subtract 2. So 3 times negative 2 would be negative 6. Negative 6 minus 2 is going to give us negative 8. So negative 8 is going to be my y value. For negative 1, it's going to be 3 times negative 1 minus 2. So 3 times negative 1 is negative 3. Negative 3 minus 2 is going to be negative 5. If we substitute 0 in, we have 3 times 0 minus 2 is going to be negative 2. We substitute in 1, we have 3 times 1 minus 2 is going to give us 1. And then if we substitute in 2, 3 times 2 minus 2 is going to give us 4. Okay, and again, kind of quick check. You can always tell if you're doing this right for a linear function because this number here is a 3, the number in front of the x, our coefficient. So because that is a positive 3, you should see the y column increasing by 3 each time. Okay, that's just something to kind of look for. Now, you'll notice I put this extra column on here. You're probably wondering why I did that. That extra column is just going to be for the coordinates. So for this column, for the first value, we're going to have negative 2, negative 8. Then we're going to have negative 1, negative 5. Then we're going to have 0, negative 2. Then we're going to have 1, 1. And then we'll finally have 2, 4. Okay, so those are the values that we're going to be plotting on the graph. And right now I'm just going to kind of put these over here out of the way. Okay, we'll just make some room over here to be able to fit this on our graph nicely. Now, when you're starting out with this, there's a lot of good graphing programs out there. I recommend using Desmos. Really good graphing program. You can do a lot of stuff with it. And it's a great way to check to see that you're doing it right. Because, like we said before, this function is a linear function. So we want to make sure that when we plot our points, we're actually ending up with a line. So let's see. So we start off with negative 2, negative 8. So we have negative 2, negative 8. And that barely fits on our graph, but we have it. And then negative 1, negative 5. And then we have 0, negative 2. Then we have 1, 1. And then we have 2, 4. Okay? And this, again, we're going to assume in this case that we have a continuous function because obviously we were only given a function rule. So I think that's a safe assumption. And that's what your graph would look like. That would be the function of f of x is equal to 3x minus 2. So we're going to try another function in just a minute. All right, so you can see here's another function that we're going to use. This time f of x is equal to negative x over 3 plus 1. Now, if you remember from the last time, I told you there's a set of values we always kind of like to use. This is going to be one of those instances where those values are not really going to be the best ones to use. So, we like to use that negative 2, negative 1, 0, 1, and 2. Only because they're kind of centered around the middle, and it's going to be, you're going to include both your x and your y axes in your graph. So in this case, though, we would end up with some nasty numbers, and we don't really want to have to plot bad numbers. So when we look at this, you can see our denominator is a 3. So we want our x values that we use to be multiples of 3. Okay? So I would probably make the first x value negative 3, and then 0, always like to use 0, and then positive 3, and then positive 6. And again, we know our function is negative x over 3 plus 1, so we're going to stick that in there, and we'll put our coordinate over there. And now we have to substitute in. So we have negative, and then negative 3 over 3 plus 1. So negative 3 over 3 would be negative 3, and the opposite would be, negative 3 over 3 would be 1, because we have the opposite out here. So we really have 1 plus 1, which would give us 2. And then we have negative 3, 2. The next value would be 0. So we have 0 over negative 3 plus 1. And hopefully you can see that's going to give us 1. So we have 0, 1. Then we're going to use 3. So we have 3 over negative 3, which would be negative 1. Negative 1 plus 1 would give me 0. So that's going to give me 3, 0. And then if I put in 6, I'm going to have 6 over negative 3, which would be negative 2. Negative 2 plus 1 is going to give me negative 1. And that's going to give me 6 and negative 1. Now, again, when you look at these, you should look at you see the pattern that happened in the y column. Okay, so we ended up with all integer values there, which is the reason that we chose those x values to start with. Just going to make it a lot easier when it comes to graphing it, because you don't have to estimate. You can just put, you can put your point right on the intersection, of the x and the y. So there's no guessing involved. And in math, we don't like to guess. We like to know. So here we go. Make a little room here. And now we're ready to plot. So I have negative 3, positive 2. I have 0, 1. I have 3, 0. And I have 6, negative 1. So again, take out your straight line. Kind of important to use a straight line here. So we would have something that looks kind of like that. And again, you can just kind of tweak it to get it exactly where you want it. Okay? And that is what our function would look like. So again, our process that we're going to use is we're going to first find the coordinates. We're going to find some points. So we make a table of values. Once we have the table of values, we can then have coordinates. Once we have our coordinates, we can plot it on the graph. And you can see, actually graphing a function, not that hard. Thanks for watching. Remember, if you liked the video, tell me.